In this video, we're going to evaluate two definite integrals, and the two formulas we're going to use are going to be these right here. See, for the second one, we're going to use this formula here. The integral of du over u squared plus a squared is equal to 1 over a arctangent of u over a plus c. And for the first one, it's going to be the integral of du over square root of a squared minus u squared is given by arcsine of u over a plus c. If you don't have access to these formulas, they can be derived using trig substitution. The first one will involve the tangent substitution, and the second one will involve the sine, using the sine substitution. And I've derived both of these in other videos and have used them quite a bit. So I'm going to assume that you have access to these formulas here, and we're going to look at the first one. If you look at the first one here, first, of course, these are definite integrals, but that's the same thing. You still have to compute the integral and then apply the limits. So notice this one is in the exact form that we needed for the second one. So the second one here is going to be used for the first one. It's dx, that could be a du, over 25, that would be your a squared, and then the u squared, that would just be x squared. So there's no kind of substitution that you have to use here. You just go directly to the formula. So here we go then. Be the integral then. It's set up for us. This should just be arc sine of u. In our case, u is x. We just put an x here. Nothing else needed for this one. And the 25, that would be your a squared. So a would be 5. This would be 5 here. And then we just apply. You don't have to change the limits of integration. We didn't change the variable or anything. So this goes from 0 to 4. And we just evaluate them. So this is just arc sine. Plug in the upper limit, that's going to be 4, so it'd be 4 over 5, so it'd be 4/5, minus the value at the lower limit. So that'd be arc sine of 0. 0 over 5 will give me 0. And the arc sine of 0 is 0. And this is actually the exact answer. But if you use your calculator, set your calculator to radians here. Arc sine of 4/5 will give you decimal 9273 to 4 decimal places. So decimal 9273. That's all you need to do to this one. Now the second one fits the form of this one here, the first one here. Integral of du over u squared plus a squared. These could be in a different order. It could be a squared. The constant could be first, a squared plus u squared. The value is given by value of the integral would be given by 1 over a. Of course, here we're not going to have constants of integration because we're dealing with a definite integral. Be 1 over a arctan of u over a plus c. So this one is not exactly in the form that we wanted. So we have to do a little bit of work with the U-substitution here. So let's just let's write this as 3x quantity squared. That'll be the u here. So I'll let u equal to 3x, then du would equal to the derivative of 3x is 3, and then it'll be dx. So dividing through by 3, yeah, dx is equal to du over 3. So let's start it over here then. And I will have to change the limits of integration here because I'm changing the variable here. So let's see, for the lower limit, x is equal to 0. So replace the x by 0 here. So when x is equal to 0, u is equal to 0. So the lower limit is still going to be 0. And when x is equal to 2, square root of 3, and then you're multiplying this square root of 3 here, the square root of 3 here, and we multiply by the square root of 3. That gives me the square root of 3 up here. And then I'm multiplying by 3 here, so this is going to give me 3. Radical 3 times radical 3 is 3, and this is going to cancel there. So the upper limit is going to be 2 square root of 3. And then the dx is replaced by du over 3. I'll put the 1/3 out in front here. And then this will be 4 plus, and then the 3x is going to be your u, so this will be u squared. So now this part right here looks just like the first formula there. Got the 1/3. So the 1/3 is going to be out in front. And then it's going to be also a coefficient of 1 over a. You see it here. 1 over a also. And our a here is 2. 2 squared is 4. So this will be 1/2. And then it's going to be the arc 10 from right here of u over a. Again, 2 squared is 4, so a is 2 here. And then we evaluate from 0 to 2 square root of 3. So this gives us 1/3 times 1/2. This will be 1/6 here. And then we evaluate. Arc 10, replace the u by 2 radical 3. The 2's cancel out, and we get radical 3 here. And then it's minus. And then we evaluate it at 0 here. So this will give me arc 10 of 0. That's going to be 0. So all I have then is 1 over 6 times the arctangent of radical 3, which is pi over 3, or 60 degrees. If you're looking at this in degrees, usually we go with radians here. So the exact answer to this one is pi over 18. Pi over 18, you can approximate if they ask you to do it, use your calculator. And this should be a decimal 174 by 3. So the exact answer is pi over 18, or decimal 0.174 by 3.